Hey, so instead of using the Loom, I think I'm just going to use the native PowerPoint Microsoft to do the last recording of my current course. So this presentation we're gonna go through is basically like a final project that we kind of combined all we have learned in the last few weeks. And this one is more like a summary analysis study. Utilizing one of my work example as like a great consolidation of methodologies and research techniques that we have introduced. So here we go. So my name's Snow, and we're gonna do problem solving and actionable analytics final project. All right, again, I'm gonna use my workspace Regions Bank to start over. So Regions Bank is a major financial institution with a significant presence in the southern and midwestern United States. The original bank, their size and diverse service offers um, numerous opportunities for problem solving, for personal finance, corporate financing, stuff like that across different business areas. So I am just going to use a pretty simple thing. It's called loan default. We all know about it. So everybody, I would say 95% of people probably have a loan, and some of them have, experience with late payment or defaults. Um, so according to my company's policy, I couldn't use any of their data, so I just found some public data set from Kaggle. The link is provided here. And all I want to do is try to predict the likelihood of loan defaults based on different features or parameters. And we want to making sure we have both, qualitative and quantitative variables or factors. And then we want to make sure there's big data. So if we want to use Monte Carlo simulation or whatever, that's enough data to do it. So this one we have about 20,000 observations, and I believe this data set provides valuable information on loan characteristics and the borrower attributes. It kind of allows us to analyze factors contributing to loan defaults. All right, now we'll dive in. So the key variables is the first thing we want to do is try to either run like principal component analysis or any of the regressions to kind of understand, okay, what are the most important variables? What are the variables that has the highest predicting powers? So first of all, we know the target variable or the dependent variable is going to be default, or how is this loan going to default based on different scenarios. And then the independent variable or the predictors would be loan amount, interest rate, the term, which is loan duration. So for example, you could have a 30 years mortgage loan, or you could have a 5 years personal loan. And next you have your income level and other categorical, anonymized features. So I believe these variables kind of offers good insights into both the loan terms and the borrower's financial situation. Kind of, the most, first come to head, crucial factors for predicting any of the loan performance. Not only the default risk, but there's, prepayment, there is, like duration, or like, how fast you can get your principal back, stuff like that. So this is pretty much a comprehensive data set that can help you predict anything. But we're just going to focus on loan default right now. So for data preparation, it's pretty easy. It's downloaded in Excel from Kaggle, examined, the missing values, outliers. We talked about how we want to, um, so in the previous classes, their Excel functions help you to do stuff like that. I am more like a Python user, so there's different fill NA, which means fill the non-value cells based on either you can use a JSON cells, or you can use like the average of the column, stuff like that. And then we want to upsample default loans for better signal extractions. There's some other anonymized sensitive information, and we want to draw a few initial plots to examine the distribution and relationships. So we're gonna go through some of the charts. I'm not gonna throw every descriptive analysis charts here. That's just not what we're gonna do. We're gonna focus on the results. We're gonna focus on the findings. So basically, this step is really just involves addressing class imbalance, protecting sensitive information while ensuring data quality for analysis. The most important thing is, how we deal with the missing values or the outliers. All right. So I think, the main question of this one would be what factors are the most accurately predicted the likelihood of loan default? The regression, the coefficient, correlation, whatever matrix you want to use, you want to make sure the factors you use are going to be the least you need, but providing a, uh, you know, very acceptable predicting power, such as like 95% to 99% based on whatever, you know, uh, you can use mean square error, you can use R squared, whatever you want to do that kind of provides a good comparison between the test data and the model data. And the second question would be how do loan characteristics influence default risk? So okay, now we have idea what are the main variables and how much influence does it pass it on to the default activity. Last one would be, are there correlations between borrower attributes and default probabilities? So on the right, this is a correlation matrix that we always use. So there's a specific Python package called Seaborn that can provide some beautiful correlation matrix like this. You can also, this is more like a heat map versus and a correlation matrix. I think for this research question analysis kind of aims to identify the key predictors of loan default. So the darker the color, the more influential it is um, to the target variable, and then kind of improve the risk assessment and decision making processes. All right, now, okay, so we're gonna predict a default rate, and that's most of the time a binary situation. Yes, it's gonna default or no, it's not gonna default. So logistic regression, we have done a few assignments and analysis on that. And this is still going to be the one we're going to choose for the default loan default analysis. So the rationale would be, it's very suitable for binary outcome. It's very easy, and most of undergrad students would know how to do it or heard about it. There's tons of advanced skills, machine learning algorithm you can use online and you can search it up. And most important thing is we have used it before. We're just gonna use it again, and it's very easy to interpret. So the model variable is gonna be the loan amount, interest rate, as we just mentioned before, the term, the income, and there's some other interactions in the relationship between other variables. So I think the logistics regression allows us to model the probability of loan default based on multiple predictor variables and their interactions. And the most important thing is do not overfit, right? So there are limitations to different regression techniques, and we'll talk more about it. All right, so here is the model output. So as I said, I don't like Excel at all. Excel is so slow and it's so um, it has its own limitation in different ways. And it's not scalable. Anyways, all right. So here we're looking at a like the predicting power curve. So we have coefficients and significance level for each variable. We consider the interaction effect between amount and interest. And for the model performance matrix, there is different AIC, AUC for model predicting accuracy or performance rating. And if you want to look more for like what is AIC, what is AUC, feel free to Google it. So what we're looking at on the right is a AUC curve, and it's basically tells you okay, how can you have the least amount of variables that provides almost the best predicting power. So make your model simple but powerful. So this model output kind of provides some good insights into the relative importance of each factor. This is just one example, um, but it will provide some great, relative importance of how the factors influence the predicting predictions of loan defaults and overall model performance. All right, so here's the key findings. So we can look, this is called elbow curve or lift chart, whatever you want to call it. So basically they're saying, okay, your predicting power kind of dies out, after nine variables or something. So you don't need 20, 30 variables within 20,000 observations. All you need is probably up to nine, up to 10. And the most important factor in my analysis is the interest rate. So interest rate is a really strong predictor of the default risk. The larger loan amount also associated with lower default probability. Interaction between amount and interest rate is obvious, and there's term length and income also contribute to the default. So these findings highlight the complex relationships between loan characteristics and default risk. It kind of offers, good insights for risk assessment, and eventually it tells us what model can we use, or how simple or how concise a model we can use for a quick analysis. All right, so business benefits pretty easy. By implementing these insights, the bank can really optimize their loan portfolio, balancing the risk and returns more effectively, improve the risk assessment. And I take responsibility of all banks' loan pricing, deposit pricing, savings, checking, CDs, MMA. So basically, the pricing of the loans is the main factor of understanding the profitability level of the company and the capital market deals or capital market trends, based on the portfolio construction. Um, so definitely, by being able to accurately predict the loan default rates, you can provide some good data for the secondary market or capital market partners so they'll understand, okay, how good the portfolio is, and then we can negotiate on the spreads and we can liquidate our assets and maintain our probability level high. Yeah, so basically all that said, number three, enhancing our decision making, for loan approvals, for portfolio constructions, and potential for reduced default rates. Understand why it's defaulting, or what kind of industry or vertical sectors are doing less defaults than the others. So that might be the one we're going to expand about. All right. Next one. So some future research considerations. We can explore additional modeling techniques such as random forest. We talk about decision trees. Random forest would be very similar. Neural networks, deep learning, all that stuff. Investigate time series aspect of loan performance. We'll also cover time series in this class, so that's being discussed. Analyze the impact of a macroeconomic factor on default rates. That's the huge thing in banks, for example, Federal Reserve just cut their rate 50 bips. That's a big move. Or the Japanese government is raising their interest rate in 25 bips in 30 years uh, it's because of the labor numbers or whatever. So it's just macroeconomics is gonna be always the main thing that's kind of a interaction between central banks, governments, regional policy, geopolitical issues, stuff like that. So it's always a combination of everything. And lastly, would be develop a comprehensive credit scoring system. That'll be something interesting too, because there are so many people do not bank. You don't have their data, but there are other things you know, you can kind of try to understand their payment history, customer behavior finance by develop a comprehensive credit scoring system, not only just by their income and the basic financial data, but there's like internet data. How they do they have I don't know, like a hate comments in one of their social media? Are they reported by some restaurants or receptionists because you were rude, or are they banned by the airlines because you were misbehaved? Stuff like that, can provide a better profile for people. But data privacy is always number one thing. So how to acquire those data would be very tricky. All right, so here's our references, and here is I think this is the end of the class of the individual assignments. They're happy to be part of the class. I really hate the Loom software, but all in all, this class is very informative, and I hope everyone has their best journey. Looking forward. Yeah.